Hey guys, welcome to my channel. And today's problem is max area of island. So you are given M cross and binary matrix grid, an island that is a group of ones representing land, connected four directionally, horizontal and vertical. You may assume all four edges of the grid are surrounded by water. The area of the island is the number of cells with the value 1 in the island. Return the maximum area of an island in grid. If there is no such island, then return 0. So we are given a 2D matrix of m cross n size, and 0 represent water and 1 represent the island. So we need to return the maximum number of islands which are connected horizontally and vertically, and which is 1, 2, 3, 4, 5, and 6 for this particular example. So for this, we can traverse all the given grids here, and once we encounter an island that is one, then we can do a DFS and calculate the uh, connected islands with it. So once we encounter a island, then we do a DFS, then we go to the next connected island, and the next, and uh, that's how we will proceed. And so we will end up with the number of connected island for this particular grid, and that's how we will compare with all other islands counter, and then we will return the uh, maximum counter. So first of all, we need a counter that is int count, and then assign it to 0. Now we need a loop to traverse each of these grids. So for int I is equals to 0, I less than grid dot size, and then I plus plus. Similarly, another loop for parsing each columns. So in j equals to 0, j less than grid of I dot size, then j plus plus. So once we are here, then we need to check whether this particular grid, this particular index, in this particular index value, we have our island or not. So it will be 0 or 1. So if it is an island, then we need a counter for that particular island, connected islands. So we will make it as current count, and we will assign it as 0. Then uh, we can do a call a function DFS, and we can give the grid, then we can give the current counter. Okay, then we need to compare. Once we have the current count, then we will compare our current count with the global count of for this particular grid. So if it is greater, then we will assign count as current count. So this is fine. Now we need to define another function. So let us just make its return type as void, and then call that function DFS, which requires the grid as a reference. and then it also requires the counter variable also. So in the DFS, what we will do, we will just check. Also, we need the index values I and j. So we will pass that also here, I and j, and that will be int I for row and int j for column. Now we will check here whether our I and j is in the boundary, given boundary or not. So it may happen that I may exceed our row size, and it may happen that j exceed our column size. So we will put a check here if I is less than grid dot size and I is greater than or equals to 0. Similarly, we'll put an and also here also. If j is j is also inside the boundary of this one, mm, grade I dot size, and j should be greater than equals to 0. Also, our grade of I and j should be equals to grade of I and j should be equals to 0. Sorry, 1. So once all these conditions are fulfilled, means we are inside this particular grid, and the value of that particular index is 1. So first of all, we will do current counter plus plus double R, current count plus plus means we have consumed that particular index, and then once we have consumed it, we will make that grade of I and j as 0. The next thing we are going to do is traverse in all the four directions. So DFS grade current count I j. So first of all, we will move uh, upwards, then downwards, then towards right, and then towards left. So we will do a DFS in all the four direction and check the same condition and do a current count plus plus. Also, we need this as a reference. Why? Because we are not returning here. We are not returning for anything from this function, and we are using the same variable to compare here the global count. So that's it. And at the end, we will return the count variable. Let us run our code. So output is as expected. Let us submit also. So our solution has been accepted. If you like my solution, then please subscribe to my channel. And if you have any other suggestion or comments, then please comment in the comment box. Thank you for watching.